All right. So, hello and welcome everyone. We are live right now. Welcome back to this amazing platform of Tutee learning, right? So, in this lecture or today's discussion is going to revolve around the next chapter, that is AD under the curve. I hope you are all excited for this new chapter, AD under the curve. And with this particular lecture, we have already finished the definite integral, right? So if you are new to this particular channel, I would request all of you to please go back to the channel and check out the playlist that I have already covered on definite integrals. Alright, so once you are done with definite integral, I think area under the curve won't be any difficult or a new chapter. It is just like the continuation of whatever you did or you studied in the definite integral. So rather, I would call this particular topic of area under the curve as nothing but simple applications of integrals, right? Now, applications of integrals in this particular topic, why I need to cover it under a specific topic? The reason is very simple. Sometimes students who are basically directly coming to watch these lectures might not also have a good understanding of the curves, right? So if you are not good with curve sketching or mathematical representation of the curves, then this particular lecture is going to serve you with the basics purpose that is going to help you out in understanding the graphical transformation and how do we do or go around with making the curve sketching, right? Along with that, in this particular topic, we are also going to see even if you have any complex function whose graph or graphical idea is not that easy to draw, then also we can try to figure out some of the critical points in the x-axis and then we can try to plot the graph based on our idea and estimates. Right. So I hope this particular idea is clear to all of you. And with that particular thing, let's get started. Okay, so I welcome all of you to this new topic of area under the curve. And again, if you're new to this particular channel, please subscribe the channel and please hit the bell icon to never miss out any upcoming notification or content that we are basically coming live every day, right? So if you are following this channel for a long time, you must be understanding that we are coming live on this particular channel, not only with topics of mathematics, but also with chemistry, with physics, and also for our NEET aspirants or NEET prepared students, we basically also have our own channel that is TUT Learning NEET. So this particular channel is a TUT Learning JEE channel, right? So in the NEET channel also, every day at around 10 p.m. you're basically having biology lectures. Okay, so if you're someone who is also preparing with NEET examination along with your school examination, or someone who is sitting for both JEE and NEET examination, they can take the help of both the channels itself, right? So if you are again, and also share this channel or these videos with your friends, with your relatives, or anyone or any junior who or he or she who must be preparing for the JEE mains and JEE advanced examination. So just to let you know all know that these particular lectures are basically taken to cater the interest of the students who are preparing for any engineering based examination. Okay, so wherever the syllabus is basically based on the NCERT based curriculum of class 11th and 12th, this particular lectures is going to cater all those interests of those general readers and curious minds of the students, right? So with this, let's get started. So today, first of all, we're going to start with sketching of some common functions, right? So I'm going to draw some of the sketches of some common function, and then we are going to step by step go forward with it, right? Now, I hope you all know how to draw a straight line, right? And how does the equation of straight line looks about? I think you all have covered that in the last class, or maybe in the last session, right? In class 11 you must have already studied about coordinate geometry, and there you have seen how do we plot the equation of any straight line, right? So that is all we have already covered, and today we're going to just do some recapitulation of the basic things. And so along with that, I'm going to show you how do we plot or sketch the region that is bounded by the linear inequalities, right? Now every one first degree equation, every first degree equation, okay, so every 1 degree equation in x and y, okay, so whenever you have any 1 degree equation in x and y variable, it represents a straight line. Okay, so whenever you have any 1-degree equation in x and y, it represents a straight line. Right? So whenever you have any 1-degree equation in x and y, it actually represents a straight line, right? So therefore, if I simply give you an example, ax plus by plus c is a simple or general equation of a straight line, right? Now from this straight line equation, I can take out many information from this. Is that first information that I'm going to take it out is what is the slope of the straight line? The slope of the straight line is simply given as negative of a upon b, right? This is given as simply negative of a upon b, right? And if I ask you what is the y-intercept, you're going to definitely say me just put the value of y is equal to 0. So if you put y is equal to 0, this particular equation, the y-intercept is going to be equals to minus c upon a, right? So these are the two crucial results that you must remember from this particular general equation of a straight line, right? Now you have already covered it, so therefore I'm quickly coming up to the idea of linear inequality, right? Now, okay, so if you still have any confusion how we are writing the slope is equal to minus a upon b, I would recommend all of you to please convert this into the form that is y is equal to mx plus c, where my m is nothing but the slope, or which can also be given as tan inverse of alpha, where alpha is the angle made by the line with the positive x-axis in the counterclockwise manner, right? So if we have this information, then now I'm in a position to draw the equation of the straight line. Also, one more information is important, that is your x-intercept, right? Similar to y-intercept, your x-intercept is also important, right? So x-intercept is basically given as by putting x equal to 0. So my y or x-intercept will be equals to minus of b upon c upon b, right? So please note these following results, right? Now we will slowly proceed to understand how do we interpret the region by linear inequality. Now in terms of, so we are not going to talk in terms of equality, now we will talk in terms of linear inequality. Okay, now we will talk in terms of linear inequality. Okay, so what do you actually mean by linear inequality? So you will have a linear equation and that will be not equal to something, that will be given as some inequality results, right? It will be less than or greater than some number, right? So let's say I have a simple example. Let's say I want to plot this particular region. Let's say I have a linear equation ax plus by plus c is greater than or equal to 0, right? If I want to plot this particular graph, or if I want to, it's not a graph, right? First of all, whenever we have inequality results, that is certain sets of x comma y or certain order pairs of x comma y is going to satisfy this particular inequality, right? When these certain sets of x and y are satisfying this inequality, we don't get any certain straight line, we get a region of straight lines or collection of straight lines which are going to satisfy this particular equation. And when we have collection of those straight lines, that basically form nothing but a region. So this will give you the region, right? So let's quickly see. Now, if I tell you that how do I check the boundness or whether I should include, and how should I decide that which part of the region to be included while we are drawing the region? So it is very simple practice. First of all, whenever you have this kind of linear inequality, first of all, plot the graph putting equality, right? So first of all, try to plot the equation of this graph, right? Try to plot the equation of this particular equation, right? So plot this curve, right? So first of all, try to plot this particular curve, right? So if I try to plot this particular curve, it is simply a straight line. So let's say this is a straight line like this. This is x and y axis. This is a straight line like this, right? So this is my equation of this straight line. Now, in order to decide which part of the region is going to satisfy, whether this part or whether this part is going to satisfy. So when I draw a straight line, I am basically dividing the region into two parts. One is this part, which is the yellow part, and one is the second part, that is the blue part, right? So this particular straight line is dividing this entire region into two parts, 1 and 2. Now, which part should I be including in my analysis or the plotting of the region? That will totally depend upon where my any of the point is satisfying the region. So generally what we do is that, so whenever we have these kinds of equation, we try to plot, so any general point to satisfy whether part 2 or part 1 is satisfying it. So what I do is just simply, I can see in part 2 the origin is lying, right? So origin is the simplest point because x equal to y and x and y both are equal to 0, right? So if I put x and y both are 0, so we have to check that whether it is satisfying the inequality or not, right? Now let's say I have c as positive, right? So once I put x and y both equal to 0, I will get c greater than or equal to 0, right? So if I have c is greater than or equal to 0, which is already mentioned in the problem, and once I putting that particular point which is lying in that particular region is also satisfying the inequality, then I am certain that that is the given region which is satisfying the inequality, right? So depending upon where my if you take up any point from this region and whether it is satisfying the inequality or not, you can be judging whether part 1 or part 2 is the required region, right? So depending on that particular analysis, you have to judge and let know that which is the following region, right? So let's quickly take a simple example. Okay, so let's quickly take a simple example. So if I give you a simple example, let's say I want to plot the region 3x plus 4y is less than or equals to 12, right? So I want to plot this inequality, that is 3x plus 4y is less than or equal to 12. Now what is the first step? The step 1 is try to plot the curve 3x plus 4y is equal to 12, or I can modify this as x upon 4 plus y upon 3 is equal to 1. Now why I am doing this, it is very easy to understand, is that when I have this form of straight line equation, it is nothing also called as the intercept form of the straight line, where this particular coefficient denotes the x-intercept and this particular coefficient denotes the y-intercept, right? So now I will plot this particular curve. So if I try to plot this curve, like this is 4 and this is 0, 3 and this is 4, 0, like this. Now I have to check whether 0, 0 is satisfying this inequality or not, right? So if I take up this point 0, 0 and try to put in this particular inequality, I see that 0, 0 is not satisfying this inequality. Therefore, this is not the required region. So the required region which is satisfying this particular thing is going to be this particular region. Right? So therefore, I can plot this. So this is my required region of this particular inequality. Oh, sorry, very sorry. I cannot directly say based on the, because 0, 0 is less than. Oh, it is satisfying it, right? So sorry, because I thought it is greater than or equal to something like that. Okay, it's actually less than or equal to, right? So therefore, this region is definitely satisfying it, right? So 0, 0 is satisfying this region, right? So our ultimate region is basically lying below this particular line, right? So in this side, okay. I hope this is clear. Please let me know in the live chat, is this part clear or not? Please correct it, okay. Is this part clear? Please let me know in the live chat, is this part clear or not? I'm going through a live chat. Okay, if you have any questions, please let us know, okay. So this is a basic idea, starting with this straight line, and now we'll go on to the idea of any general curve, right? So we might also have any general curve, and for that also you might be able to plot the inequality, right? So we are also going to apply the same results that we learned right now, or the same idea, and we're going to do that for the upcoming questions as well, right? Along with this straight line, let's now also learn about another important curve, that is circle. Okay, that is circle. I know you have all studied circle in your class 11, right? So if I ask you what is a circle, and the general equation of circle is given something like x square plus y square plus 2 times of gx plus 2 times of fy plus c is equal to 0. Okay, so this is my general equation of any circle, right? And also please note that the coefficient of x square and y square is same and there is no coefficient of xy, right? So in the general equation of conics, when you have no when you have zero coefficient of x and y and the coefficient of x square and y square are equal, then we get a circle, right? Okay, so from here we can also infer about the certain results, that is, first of all, my center will be given as minus d comma minus f, and my radius will be given as, so r is equal to square root of, so radius will be given as square root of g square plus f square minus c. Okay, so my radius will be given by this particular formula, right? I hope you have already learned this particular thing nicely in your class 11th, right? So that's why I'm basically quickly writing these results, right? Okay, so whenever, if I have any straight line, any circle equation like x square minus a plus y square, y minus b whole square is less than or equal to r, this particular thing implies that it's a circle of center a comma b and a radius is r, or let us say r square, then this is the region which is interior to the circle. Okay, interior circular region. Okay, interior region of the circle. Okay, so this inequality represents the interior region of the circle, and similarly, if I have x minus a whole square plus y minus b whole square greater than or equal to r, this, or r square, this is the exterior region of the circle. Okay, so this is the exterior region. So this denotes the exterior region of the circle. All right, so I hope this is clear. So let's go to the next set of curves, that is parabola, right? I hope this circle is clear and it's a very straightforward thing, right? You have already studied this in your class 11 and it's just a recapitulation of whatever you have studied so far, right? If you have any confusion, any questions, please let me know in the live chat, okay? I keep on visiting the live chat as well, okay, so that I can understand if you have any questions or any queries, right? All right, so let's quickly go on to the parabola right now. Okay, so parabola, now parabola is another conics, right? Okay, parabola is another set of conics where my eccentricity, now eccentricity is some parameter which is defined as ratio of two distances, right? Okay, so if you recall whatever you have studied in conic sections, okay, so you must be able to understand what is eccentricity. Okay, so whenever eccentricity of any conics is basically equals to 1, we have a parabola, right? So that is the distance of the any point from the focus is equal to the perpendicular distance of that particular point on the curve to the directrix is equal, then we get a parabola, right? So if I talk about parabola, and there are multiple standard parabolas, so let me draw the general most parabola that we already see when we study in class 11. We see this kind of parabola which is opening towards the x-axis, right? So this parabola can be given as y square is equal to 4ax. Okay, so this is the general equation of parabola which is given as y square equals to 4ax, right? So this is the general equation of parabola and it starts as 0 comma 0. Okay, and there is one more general parabola that we learned is also that whenever we have the parabola, now I will explain these results, that why it is symmetric and how do we predict that about which axis we are going to have the symmetricity about, right? So that is something I'm going to discuss about in a topic called as graphical transformation, okay, or curve sketching, right? So when we do our curve sketching, we have to learn about all these particular results, right? So I will quickly go over that particular idea. Okay, so another set of parabola can be like x square is equals to 4ay, x square is equals to 4ay, so then my parabola will be opening towards the y-axis, okay, or symmetric about the y-axis, right? So these are the two most important form of the parabola that you must recall, okay, and this is the point or the center of this parabola, okay, 0 comma 0, right? And we all know that in this parabola, this point a comma 0 is called the focus. Similarly over here, 0 comma a is also called the focus, right? So this is called the focus of the parabola. Okay, so these are all the basic terminologies that I'm not going to repeat right now over here. Okay, you have already studied those terminologies in your previous class or class 11th, right? So I'm just quickly going over the results so that you can quickly remember or you can get a revision of that particular results, right? So I hope this is clear. Now let's go and learn about ellipses. Okay, now you must have studied that ellipse are that particular conics for which you have eccentricity is less than 1 but greater than 0, right? So whenever we have eccentricity less than 1 lying between 1 and 0 and 1, then it is an ellipse, right? So generally the equation of ellipse is basically given as x square upon a square plus y square upon b square is equal to 1. Okay, so this is the general equation of an ellipse with a center at 0 comma 0, right? I hope you recall. So this is a general equation of an ellipse with a center 0 comma 0 and a is the major axis, and please note that your a is greater than b. Okay, where 0 comma 0 is a center, and this a comma 0 and this minus a comma 0 are the two focus of this ellipse, right? Are the two focus of this ellipse. Oh, sorry. AE comma 0 and minus AE comma 0. So sorry. Okay. So it is AE comma 0 and this is basically minus a comma 0, and this particular point is the a comma 0 and this particular point is minus a comma 0, and this particular point is 0 comma b and this point is 0 comma minus b. Okay, where eccentricity for ellipse can be simply calculated as square root of 1 minus b square upon a square. Okay, now if we have b is greater than a, then please try to change the result. This is when your x-axis is the major axis, right? So please note that when you must need to have the eccentricity value of an ellipse lying between 0 and 1. Okay, so please note that you have to get the eccentricity value lying between 0 and 1. So therefore you have to keep on doing that modification depending upon whether a is greater or b is greater, right? So this is the basic idea that you all must have studied, right? Similarly, the last conic section that you have already studied is basically the hyperbola, right? So let's quickly talk about hyperbola. Okay, and that will be the last set of conics. Hyperbola. Okay, hyperbola. So if you recall, the equation of hyperbola again looks like x square minus a square minus y square by b square is equals to 1. So this is my general equation of any hyperbola, right? And it generally looks like this, right? So hyperbola is much similar to that of ellipse, only it differs by a negative sign. Okay, so all the results of ellipse are going to be valid again over here, but just there is one sign change over there, right? So this is the standard equation of the ellipse, and so if I do one modification over here saying that I write this same equation as x square by a square or minus x square by a square plus y square by b square is equals to 1. So this is my equation of the conjugate hyperbola. Okay, this is my equation of the conjugate of that hyperbola. Okay, so for this hyperbola it is look like this, right? So this is my conjugate hyperbola. Okay, and this is the equation of this hyperbola. Okay, so please note that these are the branches of the hyperbola and must be drawn simultaneously. Okay, so must be drawn simultaneously. It is not like two parabolas. Okay, please note that it is not like two parabolas. They are different curvature and different curves as well, right? So these are the all general conics that we need to recall once we are dealing with this particular things, right? Now certainly there are certain curves that we also have to keep on having expertise on as we move forward with this chapter, right? So let's now quickly jump into the idea, or what is the basic idea of getting the area under the curve, right? So we have already discussed in our previous topic of definite integral that area under the curve can be found out by doing some integral, right? And we have already discussed about a lot. So in definite integral, what we studied is that the area under the curve or definite integral actually means the algebraic area under the curve, right? And we have already discussed about this result that whenever I have any general curve, whenever whenever I have any general curve like y is equal to f x, whenever I have any general curve, I have any general curve y is equal to f of x, right? So let's say the graph look like this, okay, over here. So let's say the curve is like this something, right? And let's say it's starting from point A, and we are interested only between point A to B, right? And this is my required area under this curve from this point A to B. Okay, so this is my required area under the curve from A to B. Now we have already studied that this can be given out as integral A to B for this function f of x dx, right? Now please note that when we take the definite integral, it gives me the algebraic sum of the area, right? So it gives me the algebraic area. Okay, so when I try to find out the definite integral, it gives me the algebraic area or the area with sign, right? But when I talk about area under the curve, the most important thing that I need to ensure that it is basically a mod of it. Okay, so when I talk about area under the curve, I have to put a mod about it, because when I talk about area, I basically mean what is the total magnitude of the area that is bounded by that curve. Okay, it does not associate any sign that for the part of the area which is above the x-axis is positive, and for the part of the area which is below the x-axis is negative. Not like that, right? Okay, so when we talk about area under the curve, we mean the magnitude or the sum of the magnitude of the area, right? And when we talk about definite integral, it is the algebraic sum of area. I hope this is clear, right? Now, one more important function, one more important curve I wanted to show you, all of you, right? That is something called as asteroid. Okay. Now, asteroid is also a very important geometrical figure, and the curve of that basically looks like x to the power 2 by 3 plus y to the power 2 by 3 is equals to a to the power 2 by 3. Okay. So this is not like a special circle, it's like a special form of a curve which is like an asteroid, right? So if I draw and show you how an asteroid looks like, so first of all, if you can look and see, you can find this curve is very similar to x square plus y square is equal to a square, which is an equation of circle, right? So first of all, in order to draw this asteroid, I'll first of all draw a circle of radius r, sorry, a. The circle is of radius a, and in this circle, if I have curves like this, okay, so this is my curve of asteroid. Okay, so this is the curve of asteroid. Okay, this interior curve is the asteroid curve, right? So I can try to erase the outer part. So this is the circle part. So it is bounded inside the circle. That's why I have denoted in this particular manner. I hope this is clear to all of you, right? So once I have this idea and understanding clear, I think now we are ready to move to the next particular topic, that is called as curve sketching, right? So today I'm not going to discuss about curve sketching or graphical transformation results like those, but I'm going to solve some questions that we can see that how am I going to use the concept of definite integral to get or find the area in the curve, right? So we want to find out, first of all, I want to find out that what is the area bounded by an ellipse, right? Now this is a very famous question, right? So area bounded by an ellipse, right? Okay, area under the ellipse, right? So let me take a simple example of an ellipse, that is x square by a square plus y square by b square is equal to 1. Okay, let me take a simple equation of an ellipse. So if I try to draw that ellipse, now please note that whenever, all right, so yeah, hi Deepak Kumar. Is it asymptotic to axis? No, it is not asymptotic. Okay, you can see. I think you are asking about this asteroid, right? If is asymptotic to axis. Are you asking about this asteroid curve? Okay, so please let me know that you are asking about this asteroid or something else. but we haven't talked about asymptotes right now. So don't worry, in the curve sketching topics, I'm going to definitely talk about asymptote, right? Okay, so let's come back and let's try to understand this idea that when I mean the area under the curve, I basically means the magnitude of the area. Now, certainly, when I try to find out the area under the curve, I might have many situations where the area is symmetric about the axis, right? So over here, if you observe, in case of an ellipse, in the case of an ellipse, the area is symmetric about both the x and the y axis, right? Indira, good evening. Indra, right? Good evening. Great. So what I see over here, that if I replace the x with minus of x, I get the same result, right? So functional, so if I consider this as a function, so if I consider this as function of x and y, that is x squared by a squared plus y squared by b squared minus 1 is a function of x and y, then if I replace this with minus of x, then I am also going to get the same result, right? So I'm keeping the y as it is, and similarly, if I replace the y with minus of y, then also I'm going to get the same result, right? So whenever you replace x with minus of x and you get the same result, or y with minus of y and you get the same result, that basically means that particular curve is basically symmetric about both the x and the y axis, right? Therefore, if you look into this, therefore, if I try to find out only the area bounded by this particular region and multiply it by 4, then also my purpose is solved, right? So what I'm going to do is that, again, I'm going to cut any given distance x, I'm going to cut a very small strip of dx, and then I will find this small strip area and I will go on adding it. So when I go on adding continuous data or some small finite data, then it is summation. But when I make this finite to a very small, infinitesimal small element, then it is nothing but the finite summation converts into an integral problem, right? So therefore, this particular small area, this area is integral going from, so this is 0 and this particular point is a. So x is going from 0 to a, and then this y coordinate can be given as, so y is equal to given as b times square root of 1 minus x square by a square, right? So therefore I will have over here, so this is my result, that is b upon a square root of a square minus x square dx, right? Is this clear to all of you? Right now, and you can put the plus minus sign, but if you can neglect, because we are trying to plot the area in the first quadrant, so I'm neglecting the plus and minus thing, right? Now I just have to calculate this particular integral to get the fourth part of the area, right? So the entire area is a, so a by 4 is that particular area which is bounded only in the first quadrant. So I need to find out this particular value, then my entire area is basically equal to 4 times of b upon a integration from 0 to a square root of a square minus x square dx, right? Now if you recall the result that we have already studied, then it is a very simple result, and if you recall the formula, so by formula this result is very simple. It is x upon 2 square root of a square minus x square plus a square upon 2 sine inverse of x by a, with the limit going from 0 to a. Right. So if you plot the limits back into this equation and if you try to find it out, right, so you will get this result as 4 times of b upon a, and if you plot this limits values, so it is going to be this particular part, so is going to be 0, right, and this particular part is going to be a square into sine inverse of 1, right? So sine inverse of 1 becomes equals to pi upon 2, and don't forget there is a square by 2 over here, right? So if you multiply this result is going to come out as pi times a into b. So the entire area of an ellipse is basically given as pi times a into b. Now can you see one very close result from this, that if I make this ellipse such that my a length and this b distance that is my length of the major axis and the minor axis becomes equal, then this is nothing but a result of a circle. This will result to a circle, right? And therefore, if I am saying that if my A and B are equal, it is becoming a circle. And in this case, if you put back this result, A and B is equals, and you put this result, then area of a circle can be also found out as pi a square. So the area of circle will be given as pi a square, right? I hope this result is clear to all of you, right? So this is how we actually find the general area of any standard curves or plot, right? So for the students who have been wondering from their childhood that how does the area of a circle becomes equals to pi times a square or pi r square, right? So this is the result that why it becomes equals to pi r square. So also the result for ellipse is basically pi times a into b. Okay, so please note this result. This is going to be the basic understanding for starting on with this chapter of area under the curve, right? So in the upcoming topic, we're going to learn about the most general part of this particular topic, that is called as curve sketching. Once you know how we will plot the curve of any general function, then you are in a position to calculate the area as well, right? So now we have to do some kind of algebraic jugglery to understand or to find out that whether the curve is symmetric about certain axis or not, and then depending on them we will try to switch back and try to find out the area under the curve depending upon which axis I am trying to integrate and get the result, right? So with this particular idea, I would conclude the session over here, and I would ask all the general reader to please refer to the certain functions, okay, certain graph of the piecewise continuous function, piecewise defined functions, right? So please go back to the previous classes of functions where I have already taught the function chapter, right? So in the function chapter, please recall those basic functions like modulus of x, greatest integer of x, like signum function of x, right? Fractional part function of x, all the trigonometric functions, all the inverse trigonometric functions. So please recall those particular curves as well as exponential of x, logarithm of x, right? So those all curves, please go back and study the chapter of functions, and then we come to the next lecture tomorrow, and then we are going to discuss about the curve sketching, and with that we'll start with the finding of the area. So with that particular thing, I will stop over here. Thanks a lot for your attention and joining the session, and please, if you're new to this particular channel, please subscribe the channel and hit the bell icon, because every day we are coming live on this particular channel and we are preparing for the upcoming JEE mains and advanced examination. So if you are someone who is preparing for JEE, then definitely it's a gold mine for all of you. So please share these videos among your friends, your relatives, your juniors, and try to help us provide this idea of free education all over the world.